Hello, everyone. METRONICS has participated in this project as one of the two industrial companies that have been involved in the development of one version of the HPT equipment. Our HPT equipment is based in a machine which works just with pressure, which we have adapted to work with temperature. Okay, this is the approach we have taken this time. It has been proved to work, but as I can say you that the HPP machine that we have developed is in a commercial state in this moment. The HPT version needs just one step of further development. Okay, but you are going to see it first in video and then in our facilities. So I'm not going to speak about the parameters of pressure and temperature because they have been very clearly explained by our colleagues, and we have been focused to work always with a pressure of 600 megapascals and a temperature around 120 degrees. So the equipment should work in any of the combinations that you have heard this morning. Which have been the critical steps in the development. The HPP machines, the machines which work just with pressure, are in the limit of the current available steels. The current machines, what you want from them is to last a long time once you assume that the machine cannot improve the product. So if you make 6,000 bar and you hold the pressure for 3 minutes, or for 4 minutes, or for 5 minutes, one machine is not different from another. The only difference can be your maintenance problems and the cost of operation. So the machine cannot make a better product. So once you assume that, it's a matter of taking the machine to the limit, to the economic limit of the development. So assuming that 6,000 bar is already in the limit of a practical economical viability of the technology, of the pressure technology, adding the temperature takes the steel to an upper level. Okay, it happens that we are using some special stainless steels that it happens that this increase in temperature is significant. In other parts of the machine, there are other stainless steels, other steels that are not affected by temperature. But it happens that in these vessels, part of the vessel is affected by the temperature. So we are playing in the limit of the technology. So it depends if the machine is optimized for temperature, optimized for lasting a long time with pressure cycles. The final result can be different. Okay. Again, we are working with steels, we are working with pressure, and we're working with the stresses. In the development of the machine, of the vessel, all the stresses have been carefully studied. But what happens when you heat the machine, when you cool the machine, you have a lot of gradients in stresses that when we speak about a thickness of this kind, in a steel, the gradient of the stresses can really make a big difference in the behavior of the steel and in the long-term behavior of the steel. So, just to summarize, it's not easy. We have been working in this project for 5 years in this moment. We made some mistakes at the beginning. We have improved, and today we have a commercial HPP machine. Okay. The machine you are going to see, it's a 50-liter machine adapted to work with temperature. So with this adaptation, the capacity is reduced to 30 liters. As we are based in a standard HPP machine, we have developed a system to keep this machine cold, which is made by a recirculation of cold water inside the vessel. This is patented. We have made a manipulation of the baskets, automatic manipulation of baskets, because you cannot take a basket which is 80 or 90 degrees hot, okay? This was one of the first drawings, which has been substituted by real world machine. The company Top from Holland, one of our partners, they have been involved in the development of the sensors necessary for the equipment, to test the equipment. You are going to see in the video these sensors. Here on the left, you can see the external appearance of the sensors. Here we have some of the results we get from those sensors. And I want to be fast because it's better that you see the video and then the real machine. So, in which moment are we in this? Are we now? We have an HPT machine, 50 liter, absolutely commercial, that we can offer you if you want to buy it. We are developing a 300 liter machine, which will be available next year. And regarding the combination of pressure and temperature, we are in a very good position to make a next step development for a real commercial machine. Okay, so we need the result. We are very happy with it, but the machine you are going to see today cannot be replicated exactly as it is. Of course, it's the first machine. If you ask me for a machine, I will do a second version with the improvements that I need to make it a real commercial machine. So. Of course, it's not a surprise that the HPT machine with temperature will be more expensive than the machine working with just pressure, because it's more complex. But as it happened with the pressure machines, the size of the machine, the bigger the machine, the less cost you will have per kilogram of use. So in this moment, the machine you are going to see is a 50 liter machine. Next machine will be a 300 liter machine, which will improve largely the cost of installation and also the operational costs. So regarding our company and regarding the development of that future second commercial version of the pressure and temperature machine, we are involved in the proposal of an instrument phase 2 European project. And we would like, in this moment, if in order to push the development of this perfectioning of the machine, we would need a customer. A customer means a product where we can focus in the heat transfer calculations, in the overall design of the system, because if you work just with pressure, it's a cylinder, you fill with product, the pressure reaches every point very fast, instantaneously, and you can treat the product, okay? But with temperature, it's not quite the same. First, you have to preheat, and the format of the product, the package of the product, will change completely the way the heat will get to the inside of the product. So, with pressure, we don't care. Pressure will get to every point of the product instantaneously. Temperature in the preheating process is a matter completely different. So for the machine you are going to see today, we have taken just a general approach where we submerge in water a stainless steel basket with the product. Depending on the product, we keep the product more or less time. We have an internal recirculation of hot water. So we have made quite a generic machine, which is not quite adaptable directly to all the products that you may produce, okay? And I think that in this moment, this is all that I can tell you in words. I think you can see better the video of the machine. Ya está, ya está. The recording, it has not been touched, okay? So that's our voice. After this test, we have made more tests, but this is what we have. He's putting the temperature sensor inside. The person on the right is one person of top from Holland. So the speed of the automation, forget about it. It's just something practical for the test. So a real machine will be much faster in the movement. So here we have in these bars here, there's a recirculation of water inside each basket. So inside the basket, there's a hot water recirculation. Okay. These pools have been made in Holland by the company Top. So there's water getting into the basket from the middle and getting out of the basket in both sides. There are some leaks in this basket, you can see.
¿Cuánto dura el vídeo? Nos estamos yendo ya para allá, porque esto ya no se entera.
Quedan 7 minutos.
Bueno,
¿Por qué dices?
Lo vamos a ver allá, porque la gente estamos un poco pasados de tiempo.
So the basket gets automatically into the vessel. So now in this moment the machine is ready to pump, okay? And then there's a first booster which fills the vessel with water, and then the big pump starts to push the pressure until the desired pressure, okay? So in this test, combined with temperature, we have been cautious, and we have reached just 3,000 bar in this moment. This vessel has reached already 6,000 bar, but without temperature, okay? So in the moment that the machine is certified, we will be able to go to higher temperature for safety, okay? So this is the end of the process. There's water coming out. Some water, because most of the water stays inside the basket. You can see here there's two pipes here, the big and the small one. The big one is for the hot water, and the small one is for the cold water, which keeps the vessel cold through the process. So all the time, during the minutes, 3 or 5 minutes of the process, there is cold water getting into the vessel to keep the vessel cold outside, cold inside, and there's hot water coming into the chamber of the product. So all the time. So one of the points we have to improve is that the heat exchangers we are using to heat the water, we are using water in the heat exchanger, so we cannot pass 100 degrees. So we have to use oil, so the water getting into the vessel gets over 100 degrees. So that's one of the small improvements we have to do in the next versions. That's one of the heat exchangers here in the back. That's the the hot one, and this is the cold one. So these are the pipes, the high pressure pipes get it into the heat exchangers. And these are the resistances to heat the water. Here we recover the hot water. So here one of the packages broke in this test. It had too much air inside, probably. And now we just have here the cooling process, which is similar to the heating process but with cold water, and the output of the machine. Okay, that's it. That's the machine. So I prefer that you could see the video first with everything in and then in the machine, you can ask, when we are near the machine, you can ask me whatever you want, okay? So you can, yeah, it's finished, yes, the video is finished. So here, okay, well, the sensors, okay. Okay. Okay, the sensors were just there. And so to go to our facilities, it's very, very near. It's a bit more than 500 meters from here. And I don't know if all of you have got a car. I think that please speak to somebody who belongs to CNTA or with me, so we can fill the cars to go there, okay? There's a small snack there just after seeing the machine, and then that will be the end of the day, okay?